Hi there and welcome from Ventura, California to today's webinar, Scanning Ahead with Unmanned RIEGL WaveForm LiDAR, sponsored by Inside Unmanned Systems and RIEGL and hosted by WebAttract, the leader in thought leadership webinars. I'm Lori Dearman, Senior Webinar Producer with WebAttract, and I'll be one of your moderators for today's session. And in just a moment, we'll be introducing our panel of thought leaders, as today's webinar is about hearing from these experts as they address technologies designed to provide pure digital LiDAR signal processing, unique methodologies for resolving range ambiguities, multiple targets per laser shots, optimum distribution of measurements, calibrated amplitudes and reflectance estimates, as well as the seamless integration and calibration of systems. Now we've invited you, along with over 300 professionals from 40 countries, representing a variety of industries, and over the next 90 minutes, regardless of your industry segment or location, we're confident that you'll find today's webinar of value. Before we get started, Richard Fisher, publisher, InsideGNSS and Inside Unmanned Systems, would like to take a moment to welcome you and introduce our moderator for today's session. So over to you, Richard.
Thanks so much, Lori. On behalf of Inside Unmanned Systems and RIEGL, I'd like to welcome our international audience to today's webinar. We're delighted you're here. Our panel of experts will discuss best for the job analysis of LiDAR platforms, and we'll explore use cases from Alaska to Florida that describe real-world, tangible UAS LiDAR benefits from resolution to ROI. Now, I want to turn the webinar over to today's moderator, General James Poss, who is the CEO of ISR Ideas, an intelligence and unmanned aerial systems consulting firm. He's the founder and former executive director of Assure, the FAA's Center of Excellence for Unmanned Research. He's also a leading expert on UAS, having helped design the U.S. Air Force's remote split operation systems for UAS control. General Poss, thanks for joining us again for today's event.
Richard, thank you so much for that kind introduction. I really appreciate the intro, and I really appreciate the opportunity to host this webinar here about scanning ahead with Unmanned RIEGL WaveForm LiDAR. Yeah, as you probably know, if you know anything about the history of LiDAR, you realize that we in the Department of Defense, particularly the U.S. Air Force and the National Geospatial Agency, have been working with LiDAR for decades now. And I'll be honest with you, it's one of my favorite sensors. Just because we used it extensively in Iraq and Afghanistan, disaster recovery in Haiti, for example, was one of the first places we used it. But I got to admit, it's one of those frustrating sensors that I just can't get the DoD to employ routinely. You know, we'll build a wonderful sensor for Afghanistan, and then operations will ramp down there, and then we'll put it in the boneyard at Davis-Monthan. But what gives me hope is the absolutely fantastic things the commercial community has been doing with unmanned LiDAR, led by the good folks here at RIEGL. It really does my heart good as a LiDAR fan to see the fantastic stuff we're doing, and I'm really looking forward to seeing all the wonderful things that our compatriots in the commercial community are doing with LiDAR. Okay, well, that said, Lori, I think we have a poll first.
Sure do. So coming up on your screen, you will see that poll. Question is, what type of applications do you currently fly with UAS-based LiDAR? So go ahead and give us your top two.
Okay, well, okay, so I'm definitely going with civil engineering and construction, and then because survey is so big, I mean, that's going to be one too. So. All
right.
I know I'm right on this.
All right, we've got 83% on that survey mapping, so you're right there. 33% inspection power lines, electrical grid, 26% forestry, natural resource management, and 22% civil engineering and construction mining. So any thoughts there?
Well, as I said before, survey and mapping is kind of a broad term, so I imagine a lot of people went with that. Now, it'd be interesting to talk with folks about why they think LiDAR is so much better for power line inspection and grid work than it is for construction. To me, the real benefit from LiDAR is that wonderful 3D resolution that you get off of it. And I'll be honest with you, I see that of more use in the construction and civil engineering world than I do in the power line world. But prove me wrong there, speakers. I know we've got. I know you guys will be talking about both of that. So.
All right, and Folks watching, if you have anything more to say, you're welcome to put it through the questions panel, and we certainly appreciate hearing from you. All right, let's get back to our presentation.
Okay, all right, and let me introduce our first speaker, Mylin Trong, who is the Unmanned Laser Scanning UAS Segment Manager at Regal USA, located in Orlando, Florida, which serves as the North American Sales, Training, and Support Center for Regal Laser Measurement Systems. Ms. Trong has been with Regal USA since 2010, where she previously held the position of Training and Support Manager for Kinematic Systems. Her focus since 2015 has been to expand and develop the UAS LiDAR marketplace. Ms. Trong holds a Bachelor of Science degree in Electroengineering from the University of Central Florida. So over to you, Mylin.
Thank you so much for the introduction, General Paz. Hello, everyone. Welcome. Thank you so much for joining. Just a little bit about Regal. So last year marked our 40th anniversary as a LiDAR industry leader. We have built our foundation on a wide variety of products, primarily industrial laser scanning, tripod or static-based laser scanning, mobile or ground vehicle-based platforms, manned aerial platforms, and of course the entire reason why we're here today, the unmanned applications. So Regal is the only LiDAR manufacturer that provides engineering and survey grade accuracies for a wide variety of UAS applications. Primarily, we focus and feature dense, accurate, and feature-rich data from our platforms, which you will later see discussed by our other panelists. What we have here and what we offer is, as of 2014, we introduced the VUX1 product line, which we then expanded to called the VUX1 UAV and our longer range VUX1 LR LiDAR sensor. It was the one and only engineering and survey grade accurate LiDAR sensor for UAS applications at the time. However, with the response to the size and weight of that particular sensor, in 2016 we unveiled our mini VUX1 UAV LiDAR sensor. So smaller in weight, lighter in size. It offers a different niche application with regards to an entry-level but still survey grade accurate capability, and with that we expanded to the Mini VUX1 DL the year after that, which is built on the same foundation but has been optimized for corridor mapping applications. In addition to that, we also offer a topobathymetric LiDAR sensor called the BDF1. This is a bathymetric profiler which offers the capability of cutting and measuring transects across a water body. With all of these LiDAR sensors available, of course, you need to integrate an IMU and GNSS system to get the 3D capture. So the benefits of that, we offer the integration with a Planix sensors and systems, either the APX15, which is the lightest weight IMU GNSS solution, but we really like to focus on the higher grade accuracy, the APX20. So you'll see that that is available across the board with our sensors in the marketplace. Once you select your LiDAR payload, of course, you need to take into consideration the platform to mount your LiDAR system onto. So Regal has our own aircraft called the Rycopter. The Rycopter and the heavier lift Rycopter M for multi-purpose or multi-sensor capability. It's a Regal design, Regal build, Regal integrated, so from the ground up, all Regal, including our in-house developed and fully redundant flight controller system that we call Rycopter Control, or RYCC for short. The difference between the Rycopter and Rycopter M, or Bathycopter, if you integrate our bathymetric sensor onto the Rycopter aircraft, is really the Rycopter M makes use of stronger and more powerful engines to have that heavier lift capability. The Rycopter fully outfitted is a small UAS platform, whereas the Rycopter M would be considered a large UAS. So end of last year, we made our brand new introduction of the VUX 240, which is our newest lightweight UAV laser scanner. I'm very excited about this particular scanner because itself, all in, including the cooling fans, comes in at about 8.4 pounds. When integrated with the Aplanix APX20 IMU, we're looking at a payload of just under 10 pounds. That may seem a little heavy to some, but if you take into consideration the capabilities, it is a 1.8 megahertz system with a 75-degree field of view window, which gives you effective 1.5 million laser shots on the ground. Incredibly dense, incredibly rich data sets that you'll be able to capture with this platform at a very light weight and a tremendous internal data storage of 1 terabyte of storage. So you can fly all day and you won't fill up your hard drive. And when fully integrated with an IMU, you're looking at the lightest weight, highest grade accuracy, incredibly feature-rich system to use for your applications. So taking into consideration the lineup of Regal UAS sensors in the marketplace, it can definitely be a little overwhelming to figure out which one really meets your needs. And so with that, I would pose the question back to you when you're making that comparison for consideration. What you would need to look at is what kind of point density you're looking to obtain for your project objectives versus the accuracy. You'll see that there's a trade-off between our sensors of the VUX1 versus the new VUX 240. As well as the measurement range that you're looking to obtain. And that measurement range is not necessarily related to how high you are, your AGL above the ground, but really your point-to-point measurement from the aircraft to where the end of the terrain is. Say you're flying in a valley, for example, or mountainous valley. It also, you need to take into consideration what you're looking to utilize your system on. Are you looking to only make use of an SUAS platform, or are you looking to have dual usage, moving your system from a UAS to a manned aerial platform as well, in which case the VUX 240 or the VUX1 LR would make perfect sense. If we do the comparison of the MiniVux product lineup, then again, I would still say your usage application. The MiniVux1 UAV, full 360-degree field of view, so that fits a wide variety of applications. But if your focus is on corridor mapping, power line applications, then I would suggest our MiniVux1 DL, although the field of view is smaller at 46 degrees, all of the laser pulses are in that field of view, so you're getting high concentration of points, and it's really going to obtain your objective of getting all of the transmission lines, wires, and poles for that corridor map. So you've decided on your laser scanner, you've got your IMU, you've got your integrated platform. Let's talk about cameras for data colorization. We offer support of either 1 or 2 cameras, depending on the available payload space for weight and size on your UAV. The camera position will depend accordingly. You also need to take into consideration the UAV platform. For example, the DJI Matrice 600 Pro. Due to the placement of the landing gears, we would then offer our oblique narrow camera mount. So you still have the capability of the 2 cameras, but the positioning will accommodate the landing gear of that aircraft. For our nadir single camera solution, we offer support of the Sony Alpha 6000, the A7R, as well as the A7R3. And our latest is also the support for a thermal camera capability as well, making use of the FLIR Tau 2. And you can see that in action here with both RGB and thermal camera, making use of the fins on the VUX1 sensor mounting that in the front. The entire system will come in at 5.7 kilograms. That's about 12.5 pounds all in, and you'll get 2 channels for colorization, or not necessarily colorization, RGB colorization, but also that thermal camera imagery overlay with the LiDAR. You'll just export out 2 different LAS files to make use of both channels for your attribute. So how do you decide which one is the best for you? Besides, of course, the size of the LiDAR sensor, the overall weight, of course, the cost. All of that is important, but in the end, it's related to your application. What are you trying to do? That's the whole purpose of why you're flying, is to capture the data over that site. I would not say it's a one-size-fits-all solution. You can see here that can be considered a one-size-fits-most, but again, take into consideration what are you trying to obtain. So you can see here the Minivux 1DL would not be ideal for a wide area map because of its smaller field of view, but if you're looking to map in an environment with a lot of snow and ice coverage, then it makes perfect sense because of the laser wavelength. So in essence, it of course depends on what you're trying to accomplish. So in addition to our topographic LiDAR systems that are available, we also offer bathymetric capabilities, which I had mentioned before, the bathymetric profiler. Now, in response to the profiler attribute and everyone looking for a full 3D map, we are now unveiling our VQ840G. This is our most compact 3D topobathymetric system with a elliptical scan pattern, so you're getting a topographic 3D map. It is fully integrated with the Aplanix APX20 IMU. We also have space inside the system to fit either a 12 megapixel camera or an infrared laser rangefinder, which will aid in the ability of capturing the water surface for refraction correction. The entire system is or will be less than 15 kilograms, which is about 33 pounds overall. It's in its final stages. Our target weight for this integrated system is about 12 kilograms, which will be about 26.5 pounds. So it would be for a large UAS integration, but as you can see here on the right, Copter M, fully outfitted. But really the benefits of this particular system is that it has dual usage capability, flexible integration between an unmanned platform and a manned platform, either in a helicopter or a fixed wing small aircraft. So this will immediately provide that faster return on investment in that application. So once you've decided on your overall LiDAR system configuration, you can capture data such as the applications I'm just going to run through, such as forestry, to measure the diameter at breast height, transportation, I know that's a big one that's coming up, pavement assessment, which is ideal with the reflectance measuring capability of the RIEGL LiDAR sensors, railway clearance, bridge inspection or critical infrastructure, power lines and utilities, and this particular screenshot is from the new VUX 240, just wanted to make that quick mention. And last but certainly not least, geophysical risk assessment and management, such as landslide assessments. So these are just a few examples of what you can do with high quality LiDAR systems. So thank you so much, everyone, and back to you, General Paz.
Okay, thank you very much, Mylana. And I have to admit, I am going to formally recall part of my negative comments about keeping the DoD interested in LiDAR because you reminded me of the very fine work that the U.S. Corps of Engineers and NOAA is doing with your RIEGL products, probably as we speak, out of the JOBLTEC Joint Airborne Bathymetric Laser Task Force guys here on the Gulf Coast. I know they use a lot of your bathymetric LiDAR there. So formal apologies to NOAA and the Corps of Engineers. All right, so our next speaker is Russell Fox, Senior Vice President for Strategic Initiatives at Quantum Spatial Incorporated, or QSI. Russ has over 25 years of professional experience in airborne remote sensing and is currently responsible for the development and advancement of QSI's unmanned aerial systems and topobathymetric LiDAR programs. Prior to QSI, Russ was the founder and CEO of Watershed Sciences Incorporated, a company that specialized in the collection, processing, and analysis of high-resolution spatial data for applications ranging from natural resource monitoring to engineering design. He holds a BS in electrical engineering from Penn State University and an MS in bioresource engineering from Oregon State University. So, Russ, take it away.
Thank you, General Paz, and thank you to the audience for joining on the webinar. It's a pleasure to be with you today, be a part of this discussion. For those who aren't familiar with Quantum Spatial, I'll give you just a quick overview. We are a full services geospatial solutions provider. We do everything from data acquisition. We have a considerable fleet of cameras and LiDAR systems to data processing, so base level processing, calibration and base products, to advanced analytics, so feature extraction from utilities to forestry applications, and then more recently cloud-based tools for managing all of this data. So we're really getting into the actual management and work assignment type tool sets. We do fly a number of different LiDAR systems, from the RIEGL 1560i for broad area applications to topobathymetric LiDAR. I think General Paz just mentioned the NOAA work down in the Keys, which we're involved in. And then now more recently UAV LiDAR, which is what I'm going to talk about today. So with regards to our UAS program, we're really focused. We see a lot of clients that are able to purchase fairly low-end UAVs with camera systems and go out and do inspection and do local type project work. So our focus really is on the higher end applications, ranging in from geophysical risk assessment to architectural and engineering. So really on the high end mapping applications using professional grade LiDARs like the RIEGL VUX systems to complement our airborne work and some of our mobile work for clients really ranging across the board. And then, as I mentioned, the data management and processing, as we look at the strengths of the UAV systems in the collection of very high density data and multi-temporal data, we see this need arising for an enterprise level solutions for looking at how do we manage this data, how do we look at past acquisitions and compare for things like change detection. So that's really where our focus is these days. We own and operate two RIEGL VUX LRs. We actually have one, and then one's on the way. And we use these both on UAS platforms and on low-flying helicopters, depending on the application and what the constraints from the FAA are on the application. We also use a network of trusted partners throughout the country, since we do operate in all 50 states and Canada. In order to scale and to have the capability across the country, we have some trusted partners, and we end up getting experience with many of the models of the VUX sensor that Mylin outlined. So just a couple here, like Argentech's Pulse Vapor 55 with a VUX LR. We've used the VUX UAV 1 system throughout the West. And we've also have a formal partnership with Compass Data and Compass Drone out of Denver, who fly the mini VUX 1 UAV system. So we are deploying all of these systems in different regions of the country, including our own VUX LR system. And whenever I give a UAV talk, and especially in the LiDAR world, I like to point out the importance of the IMU system. There's a lot of emphasis and focus on the scanner, but really when you start looking at engineering and survey applications, we need to also pay attention to what IMU is associated with that scanner and compare that to the relative accuracy of the required accuracy of the application. And luckily, most of the time, the Regal VUX systems are associated with the higher end IMUs, the Aplonix APX15, AP20, or the APX20 systems. So, you know, it's when we're looking at an application or we're looking at deploying a sensor, we not only look at the scanner, but we look at what IMU is associated with it and tie it into the application. And then also to point out, even though these are extremely good IMU systems, they're almost an order of magnitude different than what we would use for our traditional airborne LiDAR systems like the PAWS 510 or PAWS 610 systems. So as you go up in altitude, you have to also adjust what IMU you're looking at for tying into the project. And I like to show this cartoon, and it really is, you know, in terms of our application of LiDAR and where the UAS LiDAR fits into it. And I'm showing our next gen system, which I consider the 1560i, our more traditional systems, our more cross-track scanning, our topobathy on the Regal 880, and then the UAS down here collecting very small areas, but at very high density. So we, you know, even though it's an airborne platform, we really kind of look at it differently and say, what can we do with, you know, greater than 200, sometimes 500 or 1,000 points per square meter. And we look at it almost more like putting a mobile mapper or a TLS mapper at 400 feet off the ground. So we can get super high densities and multiple look angles at infrastructure or at a force plot that we can't get from our traditional airborne sensors. So it's not really a replacement for airborne. It's more of a focus on what can we do with this new technology in these new small areas. And with that, I'm going to pause and hand it back to General Paz for some questions.
All righty. Thank you so much, Russ. And let me, I got to crack my fingers and take a look at some of the questions that we've got. Yeah, I'll tell you what, Russ, you were just on. So let me ask you the first one here. Okay, can you describe the difference between the Regal VUX LiDAR systems and you know, kind of the competing sensors on the market? And Mylan, you know, if you've gotten any, Rob too, please chime in. So I'll let you take the first whack at it, Russ.
Okay, thanks, General Paz. Yeah, I can speak to that a little bit. You know, the Regal systems were designed for professional mapping applications. So really a company that's, you know, been working in TLS and airborne scanning for 40 years, has, you know, designed a system specifically for UAS applications. We do have experience with some of the other, you know, typically a lower cost systems, but many of those were designed for the sense and avoid market and then adapted for airborne. So they behave differently in terms of their pulse lengths and the number of returns that you can get from those systems. And, you know, really when you get into the weeds, how those systems are calibrated are different and much more difficult to calibrate for high-end like mapping and engineering applications. And Mylin, I don't know if you have anything to add to that.
That sounded great to me, Russ.
With regards to the Regal VUX sensors in the marketplace compared to others in the industry, I would say that Regal has built the UAS sensor portfolio based on the foundation of our long-time existing manned aerial LiDAR sensors in the marketplace. It's just simply a miniaturization of that technology, and then of course taking into consideration the further electrical and technological developments in the marketplace to enable that miniaturization.
Okay, gotcha. Rob, have you got anything? If not, we're going to go to another question here.
I think Russ summed it up pretty much, and without like splitting hairs, just to sum up what he said is the Regal UAS sensors were designed for mapping and exactly, the uses we're using it for, and a lot of the other LiDAR sensors that are out there on the market were designed for sense and avoid, for autonomous, ground vehicles and those. And do they have their purpose? Absolutely, but there's no way they can compete with the accuracies and resolutions that Regal's providing right now.
Okay, that sounds fair enough. Okay, so here's one we got from the audience, and I got to admit, this one is a little bit near and dear to my heart because, as you saw from my intro, I worked for Mississippi State University when I first got out of the Air Force, and they do a lot of work with LiDAR and forestry. So, Rob, for you, can you talk about the species level vegetation identification you can do with the waveform data? Can you do it with this LiDAR? Do you need to add electro-optical? Do you need to add, multi or hyperspectral to do species identification?
Sure, I'll talk about that at kind of a higher level. Obviously, this is a topic that could, be a WebEx on its own, so, we don't want to monopolize the whole thing. I want everybody to remember, even with this being a waveform LiDAR and everything, this is mainly for spatial data, and it's not going to help identify necessarily species unless there's a spatial aspect that you can do that with. But adding something like multi-spec or hyperspec type camera and having that calibrated to the species you're looking for would be the benefit of using both of those. But it still has a huge purpose in forestry and being able to do, board feet, tree heights. And, when I get into my discussion a little bit later, I'll talk about some uses of actually identifying some vegetation and that with it. But as far as actual species identification, I think LiDAR can complement that, but there are other sensors that are going to need to be included on that. Mylin or Russ, if you want to jump in on that too.
All right. What do you guys think?
Yeah, I'd agree with that, Rob. I think with the higher densities, you start getting, a different vertical distribution of points that can get you closer. But species tends to be the holy grail, and usually you need some spectral data to really get at species.
Okay, Mylin, you got anything on that, or I think we got time for one last question.
Let's go for the next question.
Next question. Okay, all right. Now, this is a big one, and this may partially explain why the DoD runs hot and cold on LiDAR. Now, what is the biggest challenge you guys see with clients when it comes to absorbing the level of LiDAR data that they're asking for? I mean, do you get folks that come in and ask for every last millimeter of LiDAR, not realizing they're talking about potentially terabytes of data? Or are you finding folks realize how big a LiDAR point cloud can be and are asking for an appropriate level of resolution? So, Mylin, would you mind starting with that one?
Absolutely. So my foundation, coming from previously working with our manned aviation platforms, is the file structure from Regal is really compressed for the UAS side of things. Depending on which LiDAR sensor you choose, your entire project or lift could be 1 gig of raw data up to a few gigs. So in the end, your entire file project size is not going to be that large, where I know on the VQ-1560I, which is our highest grade, high altitude airborne system, that an entire project could be an entire 1 terabyte itself, raw, unprocessed. So for me, it's kind of strange, but in the end, our file structure is really compressed, so that optimizes for data storage on the processing side, and then the end deliverable is then exported into an industry standard file format, LAS, or even the compressed version, LAZ.
Okay, so it's all in the compression.
Can I add in on that a little bit?
Please do.
And I think one of the big misnomers on this, and we have lots of clients, and I'm sure Russell does too, that they want the raw LiDAR point cloud data, and then you give it to them and they're like, well, what do we do with this? And LiDAR is a tool to collect data to create deliverables. I would tell you that the final LiDAR point cloud is not the deliverable that most clients actually want and can't absorb. Whether we're dealing with public entities, government entities, even though it might be a 9 gigabyte file or something like that of the laser data, there's still a lot of content in there that until it's been translated and turned into a deliverable is not necessarily useful to the end client, and what they're trying to do is make the decisions as quickly as possible. So, for example, we'll collect data and help make those decisions and create those deliverables, whether they be survey plots or CAD plots or something like that, to be able to give them that useful data at the end of the day, backing it up with the LiDAR data that was collected to generate it with.
So bottom line, connect the dots was fun in elementary school, not so much fun when you have to do it with millions upon millions of them. Great point. Okay, Lori, and I think that's all the time we have. In the interest of pressing on, we're going to do a poll.
We sure are.
Okay. Okay. Let me see this one.
What are the primary benefits to deploying UAS-based LiDAR? And again, we're asking on the honor system, if you will, to select your top two. Is it improved speed of data acquisition? LiDAR penetrates dense vegetation to map ground below, can model narrow or sharp objects, transmission line and pipes. UAS is cheaper and lighter, or I prefer photogrammetry.
All right, well, I'm definitely going with LiDAR penetrates dense vegetation. And a little bit of that is that DoD prejudice, because that was the original reason we picked LiDAR, was to find quote unquote tanks under trees. Next one, I'm going to go with improved speed of data acquisition. LiDAR is pretty quick. So.
All right, well, let's take a look, shall we?
Oh, interesting.
There you have it.
Did I win?
You won.
All right.
Any thoughts on these responses?
Well, I mean, they agree with me, so obviously they're all right. But no, I mean, LiDAR is a unique sensor. I mean, it's one of the few sensors that you have that you can slice through vegetation and get down to ground level and see everything in 3D between the tops of the trees to the, the bottom of the ground there. And then, obviously, particularly when you're talking about competing against photogrammetry, is just the speed of data acquisition with LiDAR is hard to beat. So, okay, you guys in the audience are brilliant.
Okay, well, with that, back to you, General Boss.
And speaking of brilliance, we're going to go back to Russ. So let's hear the second half of the presentation.
All right, thank you. I'm glad, I put in a kind of a broad cross-section of use cases, and I'm glad to hear the results of the poll, because my very first one and actually my second one are talking about the use of UAV LiDAR to get high-resolution ground models under dense canopy. And the first one I have is a project we did last fall up on the Yukon in Alaska, and if you look across the river here, you can see that there's a landslide, and then to the left is a bridge span. And we flew this last year with traditional airborne LiDAR. And while the results were good, there were two limitations. It's fairly thick canopy to get through, and also the ability to see under the bridge and see if there's any potential slumping or faulting that's going on is sort of limited by your look angle from the airborne sensor. So this year we put up UAV with a VUX system, a VUX 1 UAV system. And down on the bottom left here, you can see our flight pattern. The versatility of using the UAV is that we can, we were able to, fly along the bank and step up the hill slope with two missions, and then go and look under the bridge, really flying parallel to the span with two more missions. So we can get some very high levels of detail. And just looking at some of this is raw data, actually, that we grabbed straight off in the initial processing, but a native pulse density, so the number of pulses we're able to hit in any 1 square meter was over 500 pulses per square meter. We had independent accuracy checks, so on the hard surfaces down to 3 centimeters, so we're happy with that. But even in the highly vegetated areas, we're able to get under 9 centimeters RMS-EZ. And this is our client here in the picture on the left. That's what a client looks like at 500 pulses per square meter. It's probably only 200 actually, because I think it's a single pass. But what's really exciting is our ability, because of the high density and multiple look angles, and because of the small spot size you get, which is kind of in the 2 to 3 centimeter range, we can get really high ground return density. So with 500 native we're at about 160 on the ground. And this is just what it looks like in a rendering. That's the ground level picture, and that's just colorized LiDAR data with the DEM under it. So very high level of detail and high level of accuracy coming off the system. Along those same lines, we had another project. This is also in Alaska that was looking at trying to get a high accuracy, high resolution DTM under some really thick canopy. This is in the coastal southeast of Alaska. So you've got some really thick understory, and very hard to get that from traditional airborne. Really a pain to walk around and survey on the ground or do anything like TLS. So we thought UAV was the right solution. And if you look at these points are actually associate with the points on the ground. So here's the ground level, and then you can see just a really nice ground plane. So a lot of ground hits under that thick canopy. And then similar accuracies as before. Kind of near and dear to my heart, since I run our Topobathy program, is river restoration projects, and we worked with Regal to test their BDF-1 system. This was, I think, 2 years ago now, on an actual restoration project. And again, we actually flew the BDF-1 in traditional cross sections. The depth here is about 6 feet deep, so a little too deep to wade, but too shallow at points to get a boat in. So we're able to quickly, in really 2 missions, fly a series of cross sections over about 1.5 miles of river. So that would be input to like a heck grass model. But what was really interesting was our ability then to land and put a VUX UAV sensor on it, and then fly really just 2 flight lines over the immediate riparian zone. And this kind of blew me away at the time, our ability to get, and we didn't have any hard surfaces, but we did take some vegetated accuracies at about 4.4 centimeters, but just the resolution and accuracy in the floodplain with just a single mission, and our ability, and I like this image on the left here to see the cut bank and even the detail in the roots on the cut bank were pretty impressive. Other projects, we've been involved in utility research specific to vegetation management. In this particular study, we were looking at vegetation threat assessment, and it really looked at what can we get out of a high-end survey grade LiDAR, and then what would you lose if you go to a structure from motion imagery type application. And we're able to do some comparisons there, just because this is a question that comes up with a lot of clients, like, hey, we can get really cool high density point clouds from imagery, where does that leave off in LiDAR pickup? So we're able to do some pretty high level application research that provides valuable information to the utility industry. And then right along the same lines on the utility industry is looking at things like pole loading on distribution lines. So this is a 500 point per square meter UAV LiDAR, and given that density on very small features, we're able to write some automated code to actually extract the power lines, and then probably more importantly to look at the attachment points. And this gets important, as you get away from, as these poles get away from the road, the ability to you're no longer able to pick them up with like a mobile LiDAR system. So, the use of the UAV to capture that data sort of, in the field or the backyard is even more important. So just a quick overview. At the end of the day, we do have to send a pilot out. We do have to send a survey crew out. So we're really looking, the value of the UAS system is what you can get from it, and how it enhances safety, how you get higher resolution and enhanced feature detection. We're still constrained by the Part 107 rules, which tend to play into how we design a project. And then it is a changing industry, keep an eye on technology, keep an eye on rule changes. So kind of as a summary slide, beyond visual line of sights, coming down the line, I mentioned the higher accuracy and the higher densities. The clients that we work with are starting to see the absolute value in the UAV application versus trying to just substitute it as a cheaper alternative for airborne. And then I mentioned this several times, what do we do with all that data? So I'll wrap it up there and pass it back to General Paz.
Okay, well, thank you very much, Russ. I really appreciate that. Okay, and we're going to go direct into our next speaker, Rob Dannenberg, who is a discipline leader and principal associate for unmanned aviation at Maser Consulting. As a discipline leader of unmanned aviation for Maser Consulting, Rob is charged with the development and expansion of remotely piloted aircraft system services for the firm, as well as planning and executing major projects. He has over 20 years of comprehensive piloting experience using unmanned aerial systems for collecting highly accurate and actionable data using a variety of specialized sensors. So Rob, take it away and tell us some more fantastic things you're doing out there in the real world with LiDAR.
Thank you, General Paz. Hope everybody's still with us here. Thank you, Russell and Mylin. You guys gave a great presentation. So I'm going to talk during this next 15 minutes about some slightly different things and more about some client challenges we've had and how we've approached that with UAS. But before I get started on that, Maser Consulting, just to guys give you a quick brief background on it, we have currently 57 107 certified pilots. We have a rigorous safety program, 40 plus UAV platforms, and several Regal Vux LiDAR sensors. It is the only LiDAR, airborne LiDAR sensor we use. We also use Regal terrestrial LiDAR scanning and mobile scanning for projects. So the first project I really want to talk about, and this was a challenge, and as General Paz referred to, some DOTs with hit and miss on airborne LiDAR data. But this project was the Central Florida Expressway down in Orlando, Florida. This is, you know, a little over a mile off the approach runway of Orlando Airport, to give everybody a little bit of an idea where it's going. And what the Central Florida Expressway group is doing is they're trying to widen to the inside median, and they were trying to get all work within the right-of-way. 38 lane miles of limited access highway, 10 bridges were affected, 100 plus acres of off-pavement survey for drainage and sound wall design, and they had an 18-month design schedule. Anybody that's worked with DOTs, when you start talking about 38 lane miles of an expansion project on a highway and only having an 18-month design schedule to be able to do this, that can be a very tight timetable. So we actually worked with Central Florida Expressway. So our project approach was to do a combination of conventional survey, mobile LiDAR, and UAS LiDAR, providing a design team with pavement survey for 15% of the line and all grades within 3 weeks. So like I said, anybody that's done this before, that's actually a pretty heavy lift to be able to do 38 lane miles worth of survey at an engineering grade design so they can start the design process, but we were able to do that in 3 weeks using a combination of these technologies. So we captured 70 plus acres of off pavement with drone LiDAR. Again, that doesn't sound like very much. We can easily, you know, collect thousands of acres, but being as close as we were to the approach of Orlando Airway and using the LANC system for airspace waivers, because this was in a LANC controlled airspace, we were only able to fly at 50 feet. So only being able to fly at 50 feet limited the breadth we could get. And anybody that understands the 107 regulations in the U.S., you can't fly over unprotected people with a UAS, and that includes moving vehicles. So obviously using a UAS on a highway project that we don't want to close the highway for, you know, we needed to look at some other options to make sure that we had good coverage and overall going. So the key benefits of the methodology we used was safety, reduced interference to the traffic coverage. We had no need to access private property, and our survey crews were safer because they were able to stay off roadway and not be close to the roadway. And the detail we got for bridges, topology, and pavement DTM was great. So what I want to show you guys real quick is this first shot. Right here's the mobile LiDAR scan. So this was actually done by a truck with a Regal mobile LiDAR on the truck. And as you can see here, there are a little bit of shadowed areas. There was a significant slope right off the roadways and everything. And the way that the mobile LiDAR works, it was not able to see those areas, but it was very phenomenal to get the actual road services and prevent us from having to fly UAS over road surfaces or do any road closures. This is actually the airborne LiDAR data, where you can see it's significantly wider. We're able to get all the way out to those right-of-ways and everything, but there's a certain area on the highway that we weren't going to be able to get because of the altitude we have to fly at, plus the shadowing of the vehicles driving on the roads, because we never flew over this roadway to do this. Once we combined those two LiDAR sets together, we were able to have a complete picture and complement that with a traditional ground survey, and we were able to turn this product in 3 weeks for the design to start beginning, and that is about 3 months ahead of what typical schedule were, and what some other companies that bid on this project said it was going to take was 90 days to get the survey to the level they needed. And like I said, we delivered all products within 3 weeks. In addition to that, we also worked with the city of Wauchula in Florida. They have a municipal airport there, and they needed to update their precision approach path indicators, basically the lighting system on any runway. And doing that, they have to do an obstruction study and make sure that those lights can be seen at certain distances. One of the catches was, and I'll show you, part of the runway here is right off the runway. As you guys can see the runway here, there's a heavily vegetated area, and this is wetlands. Anybody that's been to central South Florida understands that that is jungle and swamp right there, and it's very hard to traditionally survey, especially for top of tree levels. And what we were looking at was what were the obstruction for the views of this PAPI light system on the runway. So we worked with the airport operators and the FAA. This is not a controlled airspace. This is one of your typical smaller Class G airports. And 107 regulations would allow you to fly there, but you don't want to interfere with manned operations. And there is a large safety element. The first time we went out to the site, the airport operator told us they had, maybe 15 takeoff and landings in a month. And in the first half hour we were there, we saw about 130 takeoff and landings. And obviously that becomes, risk with UAS and everything. So we worked with the airport operator, the FAA, and actually put a TFR over this airport and closed down one of the runways for 1 hour to be able to, collect this entire airport plus the vegetation on both sides. This is just a colorized point cloud, specifically showing where the trees were obstructing the view of the runway of one of the ends. And now I kind of want to get into what I feel like is one of our more interesting projects. We do several of these projects, so I just randomly picked one. This was a dam project in an kind of an undisclosed exact location, but if you read my text, I put it in there anyway. It's Thurlow Dam in Tallahassee, Alabama. But this dam was built over 100 years ago, and they needed to do several improvements to the control gates or the floodgates at the top. They were built, like I said, the last time they were repaired was 1927. They're wood floodgates that have no manual control to them. When a water level gets up at a certain peak, they just collapse and let the water come over. One of the big issues here is it is also a hydroelectric dam, and it is providing a lot of power to that immediate region there. And because of the safety and some of the issues on the dam, there was not a good way to traditionally survey this. And all of the drawings for this dam, and here's a better idea of what the dam looks like. The last time that anything was drawn on this was 1927, and all of the measurements on these drawings said as built, and there was no accurate as built drawing on this dam. So it's really hard to do a redesign study to correct things. So our approach on this was using a combination of terrestrial LiDAR and UAS airborne LiDAR to create a 3D model. And one of the things that I wanted to do after seeing the presentation that you guys have seen, if you guys have never seen the density of like RIEGL LiDAR data specifically over some of the other vendors that are out there, but UAS LiDAR in general, it's really easy to show you a 2D picture like this and kind of give you a rough idea of what it looks like. But I wanted to give you guys a quick video fly through so you can actually see the level of density that we're getting. So obviously this LiDAR was colorized by the imagery we took at the same time, but there would be no way to model that power station right there and all those lines with traditional airborne LiDAR or even terrestrial LiDAR, because you couldn't get all the angles and everything you needed to get. So using a mixed approach, you can see the density of this LiDAR and how we were able to provide a very accurate as-built drawing for this entire dam and all the above-ground features. So the client basically wanted a civil 3D drawing certified to 1-inch accuracy. And that's what I alluded to in the questions a little bit earlier, was the LiDAR data is great, but once again, a UAS is just a tool to carry a sensor to get us data, and a LiDAR is one of those sensors to get us more accurate data at a denser level that we can do change detection on. We can see through vegetation, and we can work with old, infrastructure projects that maybe don't have current design drawings to give those accurate design drawings back, so we can update these with using modern technology. General Poss, I'm going to hand it back over to you in a second. I wanted to give a few extra time for questions, and specifically to talk about some of the regulatory concerns that a lot of people have with UAS and how LiDAR affects that to a certain extent as well. So General Poss.
All right, thank you very much. Okay, and that was very, very interesting stuff. And who knew that they could build dams like that 100 years ago? That's pretty impressive. Okie doke. All right, and as you can see from the screen here, there's where you can get some of these fantastic presentations on YouTube, the newsroom for Regal, Regal Facebook, Regal LinkedIn, Regal YouTube, and here is contact information for our fantastic presenters there. And have you got that poll ready?
I sure do. As for the poll coming up on your screen, what are the constraints to adopting a UAS-based LiDAR in the near term? In this instance, go ahead and select all that apply. It's a regulatory environment, part 107, the inconvenience of ground control points. LiDAR is cost prohibitive. LiDAR resolution is not sufficient for my needs. Or none, the constraints are outweighed by the substantial benefit. Go ahead and weigh in on that if you would.
Okay, this is a tough one. And keep in mind, I'm going with I've only missed one question, and not that I've got a 75% accuracy rate, because I just think that's still is that a D? That's not good. Well, definitely I'm going with regulatory environment, part 107 for the first one. The second one is tough. I'll be honest with you, I'm going to go with constraints are outweighed by the substantial benefit, because I really do believe in LiDAR. So got my fingers crossed. Not 100% sure on this one.
All right, let's take a look.
Fingers crossed.
Well, there we go.
Oh, man. Okay. Well, they agreed with me on the first one. LiDAR is cost prohibitive. I don't know. I guess it depends on what your requirements are for the data as to whether it's cost prohibitive or not. So it did not see that one coming.
General Poss and Lori, can I address that comment right there, that LiDAR is cost prohibitive?
Yeah, definitely, because they disagreed with me.
This is Rob with Mazer Consulting, and I hear that a lot, that LiDAR is cost prohibitive, we can't afford that. But if you actually look at the UAS market, specifically in the US, photo-based UAS, whether it's inspection work or mapping work and everything else, if you kind of look around to the market of that's been a race to the bottom, and cost is getting cheaper and cheaper and cheaper because everybody can go out there and do it. Well, at Mazer Consulting, maybe Russ has seen the same things and everywhere else, is we've actually seen significantly less demand for photo-based UAS work and a significant more demand for LiDAR work. And the return on investment that our clients are seeing and that we're seeing outweighs photo 10 to 1. So yes, there's an initial investment that is significantly higher, but we're seeing a faster return on investment using that LiDAR than even if that we have such a smaller investment when we're doing photo, we're still seeing a faster ROI on the LiDAR side.
Yeah, I would definitely agree with that, Rob. We're seeing the same thing, and I alluded to it, I think, quickly in my last slide, where that folks are seeing that value, the value proposition on the LiDAR side kind of come through with the ability to, the higher feature detection, the higher ground densities that you just can't get from the photo-based flight. So the photo obviously has its place, but we are seeing clients that once we do work, UAS LiDAR work for them, come back very quickly for more of that type of data.
Absolutely.
Okay, thank you both of you guys for agreeing with me. So I'm going to go with a definite moral victory on the second of those two questions and a clear one on the first one. So I'm still ahead in my mind. All righty. Okay, so Lori, I guess we're going to go to questions next. Let me pull up the questions, and we got a bunch of good ones here. Let's see. Okay, Mylan, what are the uses, applications that you foresee for UAS becoming, the preferred method of acquisition? What's your top use cases for LiDAR that you see there at Regal?
That is a great question. Definitely number one, as the beyond visual line of sight is approaching with the FAA, then I see the inspection and power line utility application. In the past, it was photogrammetry from manned aircrafts, and then it became manned LiDAR, or when I say manned, I mean airborne LiDAR, and now with the UAS, I would say that's one of the key target applications our users are implementing UAS LiDAR for. And when beyond visual line of sight is there, then those fixed wing UAVs are going to go, and that'll be it.
Okay, interesting answer. Okay, Rob, this one's for you, and I think everybody will probably want to weigh in on this one. Okay, so question about utility agencies. What have you seen as the greatest challenge for utilities using the VUX-1 on the UAV? Do you find they have trouble with the processing aspect? And actually, this is a good question. What have you found to be the greatest weakness in using LiDAR in general?
Okay, well, I'm going to address that to a certain extent, and I think this is a more complicated question than it looks like on its surface, because there are a lot of utility companies out there, and a lot of utility companies manage their data significantly differently. A lot of large utility companies contract that all out. All they want is final deliverables that they're processing in-house, for vegetation management, and Russ will definitely get into some of that with some of the pilot studies that they've been doing. But then we have other utility companies that we work with that do a lot of their own data collection, and they struggle with this. And I'm sure Mylin, can mention that a lot of utility companies out there actually have VUX-1s, and they use VUX-1s when they're doing their own thing. I'd say the greatest challenge for utility companies currently using, a VUX-1 on a UAV is line of sight. And that's a regulatory issue. Russ alluded to it, I think, better than I've heard in a long time, but, we all call this unmanned aviation. This is anything but unmanned aviation. I can't send a drone out by itself. I'm always sending a flight crew out. One thing we didn't hit on very much is that all UAS, LiDAR, photogrammetry, structure for motion, all of that, depending on what state you're in the U.S., is also kind of controlled by engineering and survey boards in those states. And it's not everybody can provide mapping, whether they do it or not. There is a licensure, and you've got to be able to validate accuracy. So there's ground control elements, and there's still survey crews on the ground that are putting targets down. But I'd say the utilities personally using VUX-1s, if they're not using them on manned helicopters, it's line of sight. Until they can get beyond line of sight, it's a great asset for when they're doing repairing, small pieces, storm response, and they're focusing on smaller areas. But if they're trying to, inspect, 10,000, line miles of transmission lines that some utility companies have, a VUX-1 UAV is not going to do 10,000 miles of line in any cost-effective manner. And then when it comes to the data, all of those, every utility company I've worked with wants something different. Some do PLS CAD modeling, and using the LiDAR to classify that data and get it into a PLS CAD model is actually pretty straightforward and very cost-effective. Other utility companies aren't quite there, or they don't want to use it for that. And the other biggest challenge I've seen working with utility companies is utility companies are very siloed. They have their maintenance group, they have their transmission group, they have their distribution group, they have their veg management group, and they're all there. A lot of this data can crossbreed across all of those, which helps absorb some cost if there's cost there of being able to collect that, because they're getting more data than they're used to getting, but some of them don't share that data very comfortably. Russ or Mylin, do you guys want to add anything to that?
Yeah, I think you pretty much nailed it, Rob. I think line of sight is once that restriction's lifted, I think that we'll see UAV LiDAR really expand in the utility sector. And I think the other thing you said that pretty much nailed it is, a lot of times we're providing end products to the utilities rather than point clouds. So we're, it's a derived product, whether it's a vegetation threat or a change detection. We've done work locally on substations, so we'll get the as-built on the substation and then look at, change detection over time if a storm passed, things like that. But that's, I think you pretty much nailed it on what the current limitations are.
Okay, good one. All right, here's one for you, Mylin, and this is one that people never ask, so I'm grateful someone did. Can you insure LiDAR UAS easily? Is it a reasonable price for it?
Ooh, that is a good question. As far as easily insure, I would still, whenever someone is interested in purchasing, they'll ask about insurance, and all we can do as a manufacturer would provide or refer to companies that we've worked with in the past, and those insurance companies, depending on who they are, either they have never worked with LiDAR before, or they're treating it as an aviation platform. So it is expensive equipment, but you need to treat it as a tool. It's not, UAVs are not toys, at least definitely not in our industry. And I think Rob can probably answer more regarding some of the verbiage in the insurance capabilities, but it is available, but I would still say it's niche. I wouldn't say you can call up any insurance company and they know exactly what to do compared to, say, car insurance.
Mylin, just a comment on that, and Russ is actually probably maybe even better suited to answer this question, because I would tell you, you can't use a regular insurance company to insure these. You're using an aviation insurance company doing whole insurance on your aircraft if that's something you want, and this is a payload insurance that is going to be tied to those aircraft, and safety records mean a lot to do that. But you can't look at it as insuring like traditional survey equipment like terrestrial LiDAR scanners and mobile LiDAR scanners. This is more looked at insuring it like you would aviation assets, and that's exactly what it is an aviation asset, and trying to separate it from manned aviation is where I think a lot of people go in the wrong direction on that.
Yeah, I think I can answer part of that, and since we have an aviation program and the UAV payloads fall under that, we can fairly easily, and since we own I think 13 LiDARs, we can easily add it. What I don't know, which would be a really interesting question, is if you're a smaller engineering firm and you don't have an aviation program, how that would work out, because it is a different type of asset.
Absolutely, and that's why our we do all of that from an aviation program perspective. We had to separate it from our other insurance because it is a different type of asset.
Yeah, exactly.
Okay, good answers to a tough question. All right, now this one I guess I'm gonna aim it at Russ first, but all three of you may want to get on this one because it's a good question. How useful are bathymetric LiDAR systems for mining, dredging, etc., where you're dealing with very turbid water? How well do bathymetric LiDAR see through cloudy water?
I can handle that. Turbid water is a problem, and it's kind of the bane of our topobathymetric. LiDAR is how clear is the water, and that's really going to define what your depth penetration is. I think the rating on the UAS, and especially the new one, which I'm excited about, I think it's the 840, is 1.5 to 2 secchi depths. So it's a function of the turbidity of the water, so water clarity, and then what the bottom reflectivity is. So if you look at some turbidity measurement, whether it's as simple as a secchi depth or actually taking instrument readings, that will give you a good idea what your depth penetration is going to be. But yeah, it's definitely a factor.
Okay, excellent answer. All right, so the next one is, and gosh, I think this is for Rob and Russ here. How do companies see the actual return on investment for LiDAR? And how do you guys in Maser and Quantum demonstrate the savings to your new customers? When you got a brand new guy doesn't know much about LiDAR, what do you tell them? And Russ, why don't you go first?
Yeah, I think that's evolving right now. Really the mapping level accuracies and with the UAV is really fairly new in the last 2 to 3 years, and really in the last 2 for us. So a lot of it's on the education side, and looking at, like I said, not necessarily trying to do a substitute for our current methods, but looking at it as a completely new tool. So we'll show the level of feature extraction. We will look at, what does the UAV LiDAR give you how does it compare to, say, more traditional methods, or what value can you add that you simply can't get any other way? And sometimes we try to put numbers to that, but more we kind of count on our clients, and many of them are already familiar with LiDAR, to connect those dots themselves. Oftentimes, I mean, we've got some really smart clients that can look and say, oh wow, you can do that, and then they can make the connection on the ROI for their particular application.
General Post, to add to what Russell just said, and I think he nailed the number one thing, it's education. I've had, a unique benefit about using UAS LiDAR pretty much since Regal released their first UAS LiDAR for this, and using it in comparison and to complement manned aircraft. But I think it comes down to, like, client management is, what do your clients need, and understanding this is a tool. I'm in a unique situation with Mazer Consulting being a multidisciplinary engineering firm, having 200 traditional surveyors, is we have terrestrial LiDAR, we have traditional survey, we have mobile LiDAR, now we have, UAS LiDAR, we use manned firms to do that it's a tool in the bucket. So talking to the client, understanding what their requirements are, and using this, not forcing UAS onto them, but saying, hey, this purpose is a really good purpose for UAS, and having that relationship with the client to trust that you're going to provide them the right product, and then start to show them the added value as it goes from there. But I'll give you, an example. One of our clients was very hesitant, and to go back to one of the projects we had, is Florida DOT and the Central Florida Expressway was very hesitant about using UAS LiDAR because they've done some internal pilot studies, and they were worried about accuracies that they were seeing and everything else. And it literally became an educational thing. Let's go sit down with them, find out what they were using, what were their pain points, and why are they concerned about it. And it came down to, well, they're using a $15,000 LiDAR with no IMU and trying to use a UAV grade IMU internal to, some sort of a UAV product to try to correct that data, and that's not going to do it. I mean, Russell mentioned it, Mylin mentioned it. One of the biggest pieces of a LiDAR is the IMU. If you don't have an accurate IMU, you can collect LiDAR all day long, but it's never going to be accurate. So being able to show them the use cases of, here's our true accuracies, and providing them those accuracy reports and showing them other data that we've done, and then showing them the level of detail that they're getting. And there's added benefits. Thurlow, Dam, for example, when we originally did it, it was for an as-built. But we've noticed clients come back to us all the time. They're like, hey, since you flew this, did you also happen to collect this area? Or do you guys need to go back out because now we need to expand and we need to do a construction layout area? Well, we've already collected that data. So sometimes having data in the can, helps the client in the long term, is as they're learning what the data does, we're getting more and more uses for it, which is just increasing that value to them, knowing we can fly a site once, and 6 months from now, they can ask us about something from that data that was maybe never originally scoped, and we don't have to return to the site to collect it. We already have that data to be able to pull it.
Excellent points. Okay, here's another good one. In Mylin, I'm going to ask you to take first stab at this one. What is the level of accuracy for change detection that you can realistically expect on no kidding, ground elevations that you're shooting LiDAR through significant vegetation? How accurate are you shooting through trees?
You're only as accurate as the tool you're using. So as one of Russ's slides, there were either ground control shots or check shots captured in the dense vegetation, and then you can see in that screenshot cross-section of the data that the data lines up. That's going to give you your proof that you are accurate to that ground elevation. Once you define your base map, then any subsequent data captured can then be cross-compared for that change detection. But Yeah, you're only as accurate or strong as your weakest link. So you need that ground control point to confirm that the data you have is really where you are, especially in areas of dense vegetation.
Okay, good answer.
To kind of piggyback off what Mylin said, just an average, very vegetated area accuracy that we're seeing. VVA means a lot different thing if you're in the northwest Oregon area, Washington, Alaska, versus if you're in West Texas, versus if you're in the northeast like Pennsylvania, New York, or New Jersey. But we're seeing anywhere from 1.5 inches to 3 inches on average in very vegetated areas. On hard surfaces, obviously we're getting significantly better than that, but you never know what is on that ground below. Generally in heavy vegetated areas, if you got a layer of leaf or something like that, that might be some of that disconnect stuff. But that's really where we're at, 4.4 centimeters to 9 centimeters, and I think that's very close to what Quantum Spatial presented in their presentation too.
Yeah, I think from, as we were talking about that, and I agree with Mylin and Rob completely on that, but, it's going to depend on the level of vegetation. And then we always look at our ground density. So, when we classify ground returns, we can look at the density of ground returns and then the assessed vegetated vertical accuracy. And that gives us an idea of, how much interpolation are we doing, and then what's the absolute accuracy in those areas. And then we can assess what the minimum detection unit would be. So I hate to say it depends, but you have to kind of consider all those factors together.
All right, sounds good. Okay, Rob, I'm going to ask you to take first whack at this next one, and we've talked about it during the whole presentation, but let's be blunt about it. So what are the big regulatory challenges in flying small UAS, and is it really cost effective to apply for waivers against some of the major stuff?
Okay,
take it away, Rob.
No worries. I am going to have a differing opinion on this than most people, since I've been working with SUAS from 333 exemption days into 107. I've seen some different transitions into this, but to me, the number one regulatory challenge is not the FAA, it's local laws. State laws, county laws, city laws that contradict federal laws, or people unaware of them. And, I'll give an example. I'm right next to New York City, and we've flown in New York City before, and we've done everything we could to make sure, this is a legit way to do this. From an FAA perspective, there's a lot of New York City that's not in controlled airspace, and it's pretty easy to work with. But New York City themselves has a law on the books that says no UAS can take off or land in New York City within, the major borough limits. But there are several companies out there that are doing it. We were actually working with New York City agencies, contacting, law enforcement, contacting the city, and they're saying, yep, you're good to go, you can go do this. And then we were about to do a very large, very high profile project in New York City, and it got up to the mayor's office, and they're like, no, we have a policy against this. And, and me running a professional aviation program, it doesn't matter if the federal government, says it's okay. If a city government says, no, I'm going to stop. But then that city, the actual city itself goes, well, I've got this person that said they'll do it. And I go, but you understand that I'm not telling you I can't do it. I'm telling you I can't legally do it with the way laws are currently set up. So I actually try to work with a lot of these public entities. And there's some other people that I know are on this WebEx that do the same thing we understand the concerns, and there's homeland security concerns, and there's a lot of concerns and a lot of unknowns, but without having steady rules everywhere I go, that is my biggest challenge. Is if I go to Miami, or I go to Orlando, or I go to Seattle, or I go to San Francisco, or I go to New York, there's a different rule in every single one of those places and different things I have to follow that are not easily accessible. North Carolina's state themselves, they require an additional permit to fly within the state that no other state does. So it's the disconnect of the rules, and I'm not sure what the fix is to that. As far as going after waivers and the large waivers, if you are going to be doing this type of work a lot, I think setting those ground rules, setting those SOPs, setting those procedures, getting them approved makes it a lot easier. Specifically, we work with a very specific international airport that we've been working with the FAA on and the airport on because they want us to fly weekly on runway on this international airport. So this is a Class B airport. And there's regulatory hurdles, but working with the airport owners, working with the FAA, we're creating those procedures and policies to make everybody feel comfortable about it. And you can't wait 90 days if they want you to do it every single week. So we're working on blanket waivers to cover that airport and letting that airport's air traffic control cover the specific pieces because we don't want to interfere with their operations. They don't want us to interfere with their operations. They shut down their runways for an hour every single week on a very specific date, and that's when they want us to do some of this maintenance because they're already not getting air traffic in there. So we have received several waivers, several authorizations, whether it be airspace, night. You can go after weight waivers, and everything else. There is a waiver process in place and it does work. Most people that apply for waivers and never hear back didn't actually look at the guidelines for filing for the waiver because I would tell you the FAA is very undermanned for what they do and they do an awful lot with what they have, but I don't think they have the time to look at a waiver that's just blatantly doesn't consider safety or anything else and just I should be able to do this because my drone only weighs 3 pounds so I can't hurt anybody. I probably wouldn't look at that either and not going to respond to it. I'm going to look at the valid waivers coming through.
Yeah, and I'm here to tell you, a 3-pound drone is not going to get you flying even under the new ops over people rules. So just something to think about.
Absolutely.
All right, so I think we're out of time for questions. Inside Unmanned Systems has started a new podcast, Drone Beat, and we will be covering what we just talked about here, state versus federal regulation of small UAS. And I got to be honest with you, I'll be on the state side, the side that's saying that you can't wish away the state and local guys because they're always going to get a vote on it, and you need to be proactively working with them just like you're working with the FAA. So end of the paid political announcement. So Lori, are we out of questions? Are we out of time for questions, or
I think
are
we are.
Ah, shoot. Okay. All right. Well, thank you so much for joining us on this webinar. I learned a tremendous amount, and I think I have convinced myself beyond a shadow of a doubt that the DoD is dead wrong, except for the Corps of Engineers and NOAA, in continuing to go hot and cold with LiDAR, because you guys out in the commercial world are doing some fantastic stuff with that. So, Lori, I'm going to go ahead and pass it back to you. Thank you so much.
All right, and folks, before we sign off, I would also like to thank each of you for joining us today and trust that you found it to be of value. And special thanks to our distinguished panel members and, of course, our sponsor and co-host Inside Unmanned Systems and Regal. And again, thanks for joining. This is Lori Dearman saying, hope we see you on the next one. Bye for now.